everybody. Welcome to Harper College's chemistry labs. My name is Dr. Karen Daly, and I teach chemistry here at Harper College. This is my colleague, Professor Julie Ellefson.
Hi, everyone. So we're standing in one of our prep chem labs right now, and part of what people think about chemistry is actually doing the work in the lab. Chemistry really, it has so much more to offer than just the being in the lab. So even if you don't want to be a chemistry major, we obviously did, and we love it, but there's so many other things that chemistry can help you understand. So it helps you make informed decisions. If you know something about chemistry, then you might make informed decisions about the kind of foods you want to eat, or the kind of fuel you're going to use in your car, or medications. It helps you understand all of that. And if you have a major in chemistry, then you can do all kinds of things in terms of jobs. Like you might decide that you want to be a bench chemist, or maybe an environmental scientist, or maybe even a lawyer, or a pharmacist, or work in the medical field. So there's so many options, but we're kind of biased towards the chemistry side of it because it's actually the foundation for so much more, and because it's fun. So what we'd like to do is to show you some demonstrations to show you the fun side of chemistry. Hey Karen, what do you think this is? What does it look like?
Sugar?
Salt? Why do you think so?
Because it's got little particles and it moves around when you shake it.
Okay, so you're describing characteristics of the stuff. All right, so what do you think is going to happen then if it looks like sugar or salt if we put water into it?
It's gonna explode!
Your sugar and salt explodes? You got funny sugar and salt. Well, let's give it a try.
It's not gonna explode?
Well, we'll find out. But, of course, safety first. Pick up a couple. You got those two, I got these two. We're gonna just pour the water in, all of it. Ready?
No. Yes.
Okay.
Woo! It didn't explode. Ah! It's making a mess.
That's fun, isn't it? All right, so what happened to the water? What do we think's going on here?
It disappeared.
Well, as we're well aware, conservation of matter, the water can't go away.
Oh.
So, you know that. So what happened to it? Well, the white powder that was sitting on the bottom that looked like sugar and salt, because it's a white powder like sugar and salt is, it's a white solid, it is actually sodium polyacrylate. And sodium polyacrylate is the same stuff that's in baby diapers, because this is what you want baby diapers to do. So the water is here, but it's trapped in the sodium polyacrylate. So
What's sodium polyacrylate?
it's a polymer.
What's a polymer?
A polymer is a really long molecule. So you want to know what molecules are and more about this, you got to come take a class with us. We'd love to have you. But what it is, it's a really big molecule. You have some of them in your own body, like proteins, and that help keep you alive. But what this does is it is able to absorb hundreds of times its own mass in water. This particular stuff is made a little bit differently than the stuff in the baby diapers, because we really wouldn't want the diapers exploding like this.
That would be bad.
I think it would be kind of a nightmare for parents. However, it's the same basic chemical compound, and so this just absorbs the water and it flows out. Looks a little bit like snow. In fact, we call this Insta Snow because of the way it puffs out like this. So we're just getting you ready for the coming winter.
I'm going to show you a demonstration of something that we call a combustion reaction. But before we do anything, we have to be safe. So, do you know what a combustion reaction is?
I do.
Julie, what's a combustion reaction?
We're gonna burn something.
We're going to burn something. Okay, what do we need to burn something?
We need a fuel.
A fuel. Okay, I have a fuel. This is called methanol. I'm going to add fuel. This is my fuel.
Okay. All right. Good deal.
All right. What else do I need?
We need an oxidant, like oxygen.
Oxygen.
Do we have that around?
I have some. There's some carbon dioxide in there, but there's enough oxygen. I'm gonna put a cork in, I'm gonna shake it up so I can get some of those fuel vapors going. It's not burning, Julie.
We need one more thing.
What do we need?
We need a spark.
We need a spark.
We need something to ignite those vapors.
I have that something, Julie.
Let's see.
This is a Tesla coil. You ready?
Ready. You got it. It worked.
That was combustion.
So we're going to demonstrate a decomposition reaction. So we're going to start with hydrogen peroxide, but safety first. So this hydrogen peroxide is can be used as a disinfectant, and so this particular hydrogen peroxide, however, is a pretty concentrated solution, so it's pretty strong. We're going to add a little bit more to this now to make it a little bit more colorful. So Karen, would you like to add? I'm going to put a little soap in here, and we're adding some food coloring. And so far, not a whole lot is happening here because the hydrogen peroxide is just sitting there. So we want to add something to it. And what we're adding is called a catalyst. And see what happens. The bubbling there was because when we added the catalyst to this, the hydrogen peroxide decomposed, it broke apart, and it produced a gas. And so the bubbling up was the gas that was produced, and that was oxygen gas. And a lot of heat was also generated in that process, and that's why you saw kind of the steam coming out. And it was that the gas, along with the soap, we had put some soap in there so that you got this bubbling effect. So the soap wasn't necessary for this reaction to take place. It was the addition of the catalyst that got that hydrogen peroxide to break down, and the oxygen gas was produced, and then the other product was water. But because it got so hot, we actually had water vapor, and so that was some of this, you could detect that the vapor was produced as well. So Karen and I think chemistry is a lot of fun, and we hope you had the opportunity, or we hope that you really enjoyed the demonstrations and saw the fun side of chemistry. But chemistry is so much more than that, and it can really help us to even solve some problems in the world, like environmental problems, for instance. So we're well aware of the plastic waste problem, and so what chemists can do is they can help us design materials that are actually biodegradable. And this was made by our students here. And this is a plastic-like material, so it feels like plastic and has some of those same characteristics, but it's made of gelatin and glycerol, and so it's completely biodegradable. So short of just cutting down on your plastic use, if we have different materials that would enable us to still carry out some of the same functions, but with a substance that wouldn't be stuck in the environment. And then also designing fuels. So we know that we have a need for alternative fuels, and this again is something our students made here. This is a biodiesel made from vegetable oil. And if it's made from used vegetable oil, then it would be making a fuel that you could actually burn in a diesel engine, but that's made out of, again, materials that would have just gone into the waste instead of from petroleum. So these are just a couple of examples of some of the things that we do here at Harper, and just an illustration of what chemistry can do to help preserve our environment.
So thank you so much for coming to the chemistry labs at Harper College. Hopefully you'll get to come and visit us here in person someday, and hopefully maybe someday we'll get to see you in one of our classes. And remember, safety first.